How to rebuild a vintage steam toy. This is part 6. Finding out what the thread sizes are in the top of the boiler, repairing the whistle, painting the base and making a new crankshaft. Before I continue with this episode, I'd like to take this opportunity to thank all of my new Patreon subscribers. I really couldn't do this without your support. And since YouTube, for some reason totally unknown to me, have demonetized my YouTube channel, the only revenue that's coming in now is from you, my Patreon supporters. The normal advertising monetization has been stopped by YouTube. I can appeal next month. So once again, to all of my Patreon subscribers, old and new, I thank you. Bad news lately on the YouTube front, but it's not all bad news. I've been asked to write a series of articles for a very popular model engineering magazine, and all being well, the first article should be published next month. But for now, it's back to the video. There are 4 holes in the top of the boiler, and these holes are all threaded. I don't need to worry about 3 of these threads because 2 of them take the steam and the whistle valves, the other one takes the manometer or the pressure gauge, and the 2 threads for the steam outlets seem to be 5/16 by 32 threads per inch, but that may not be correct. As this engine is of German origin, I would think that the threads are metric, and metric threads can be very similar to imperial threads when it comes down to ME and BA sizes. Of the 4 holes in the top of the boiler, I'm only concerned with one of them. I need to know what the thread size is for the safety valve. I'm going to make or buy a safety valve to match this thread in the top of the boiler. And the easiest way to find out what the thread is just to use a tap. And try various taps until you find one that fits into the hole by finger pressure alone. Do not use a tap wrench. You don't want to recut the thread. I think the time has come to give the valves a little bit of attention. This is the whistle valve, and as you can see, the operating arm is bent. That's simple enough, it can be straightened. The operating arm on the regulator valve has snapped off. I'll have to make a new one for that. I think I'm also going to make a couple of new wooden handles because this one's a bit past its sell-by date. I've polished up the cylinder covers top and bottom. This is the connecting rod, and I think it needs a little bit more than polishing. I'll start off with Scotch-Brite and work backwards, probably using some emery cloth. I don't want to over-polish this engine. It doesn't need to look like a new one, so as you can see, it's just a general clean-up. And in this clip, I've cleaned up the whistle valve too. I intend to lap the taper plug that fits into the taper socket in the valve using some T-cut cutting compound because it's not too fierce and abrasive. Here's what's left of the steam manifold. I'm going to carefully resolder the whistle onto the valve. And here I'm applying some flux to the top of the valve. By the way, this is soft soldering, it is not silver soldering. Soft soldering doesn't need quite so much heat as silver soldering. I'm using a very small gas blowtorch for this job, and I'm applying the heat to the valve, not to the top part of the whistle. Because if the whistle is also assembled using soft solder, I don't want to melt it. I'm using electrical solder for this job, and here I'm using a paintbrush dipped in water to clean up the joint. And while the assembly is cooling, it's into the outer part of the workshop to paint the base. I'm using Phoenix Precision Paints Etch Primer first. A nice even covering, but not too thick. And 24 hours later, I'm applying the first of the top coats. I bought this tin of paint from a local company called Autopaint Northern. And here's the address on the tin. It seems to be good paint. I don't know how I managed to get it on my fingers though. The whistle valve assembly has now cooled and the paint is drying. It's time now to make the new crankshaft because the old crankshaft is unserviceable. I'm going to copy this crankshaft in stainless steel so it won't go rusty like this one has. The job starts by holding the original crankshaft against a piece of 3/16 of an inch diameter stainless steel bar. I put a mark on the stainless steel and cut it to length on the bandsaw. Then it's over to the lathe to turn the end part. And why am I using a parting tool to turn this end part? I'm just doing it for the purposes of the video to show you that you can use parting tools this way. It's not good policy though, and if it's a carbide tip parting tool, forget it. You'll just force the tip out of the tool. Normally the tip of a lathe tool is slightly rounded. So by using a parting tool you can get a perfectly square edge, but you must only take very light cuts. And here's a really useful tip. When doing a job like this, before taking the final finishing cuts, it's a good idea to sharpen the lathe tool. That way you get a good finish on the work. I know it doesn't look too good on this particular clip, but it's very good. When I check the diameter of the machined end of the new crankshaft, it's exactly the same as the one on the old crankshaft. Except I've left it a bit longer, for a reason. Here I'm threading the end of the crankshaft using a 5BA die. And you will notice that the thread is also a bit longer. And once again, I've done this on purpose. There is a method in my madness. I'm just facing off the end of the crankshaft, and in this highly magnified view of the operation, you can see how much the bar bends when I apply the tool to it. I think that should do it. Time to apply the file to the work just to clean up the sharp edges. A health and safety warning: when filing in the lathe, always make sure the file has a handle. If the file accidentally hits the chuck, it will avoid injury. In this clip, I'm applying some Loctite 638 to the hole in the crankweb. I fitted the slip eccentric mechanism, then I screwed the crankweb onto the crankshaft in the lathe. And here's why I left the thread slightly longer. I've machined a standard 5BA nut to make it thinner, and I'm tightening this onto the end of the crankweb, which will stop it ever working loose. Now seems like a good time to oil this mechanism. The slip eccentric part of this has to be very free to move, as indeed does the crankshaft in the bearings. Very soon it will be time to fit the cylinder to the bracket, but not yet. First of all, I need to assemble the bracket onto the firebox, and when I do this, I would think that the bearings are going to move out of alignment, because after all it's only a very flimsy bracket, and I will realign the bearings using a piece of 3/16 bar. I definitely will not be using the crankshaft to realign the bearings. And that's it for this one. Thanks for watching, and I hope you found it useful.